Okay, guys, this is chapter 8.2. It's called the reciprocal function. Here is in the red box here, I'll put it in a purple box now, is the is kind of what a reciprocal function is. It's y equals to a. A represents the stretch over x minus h. H represents the horizontal shift, left or right, and k represents the vertical shift, up or down. Okay, here's the parent function for a reciprocal function, and it looks like this graph right here. Okay, it's kind of a funny graph. So maybe what the best thing would be to do is to just kind of, I'm just kind of running through all this right here. Maybe what the best thing would be is to do the graph of the parent function. But actually, before that, let's talk about this really fast. I want to just see where are these reciprocal functions undefined. Well, think about it. You can't have a 0 in the denominator. So if I looked at this function right here, what would make my denominator have a 0? It would be if x was equal to 1. So it's undefined at x equals 1. Because then I would have 1 minus 1 in the denominator. I have a 0 in the denominator. So what about this one? This one's a little trickier. Well, how would my denominator be 0? Well, I would have to take 2x plus 5 and set it equal to 0 and see what I get. So I subtract 5, 2x equals negative 5, divide by 2, x is equal to negative 5 over 2. So that's where it's undefined. Think about it. If I plugged in negative 5 over 2 for that, I would have 2 times negative 5 over 2 plus 5. So that would be negative 5 plus 5. So I'd have a 0 in the denominator. Here is a nice easy one. If I had a 0 in the denominator, if x was 0. So x is that. So this is where the function would be undefined for each one of those, okay? Because I'd have a 0 in the denominator. All right, now let's do the graph. If I was doing this graph here, let's put in some numbers here, okay? So first let's put in, I'm going to put in negative 1/2 for x. If I put in negative 1/2 for x, it would be 1 over negative 1/2. And if you remember, that's like saying keep, change, flip, which comes out to be negative 2. So when I plug in negative 1/2, I get negative 2. So if I go to the left negative 1/2 and then down negative 2, that's my point. Negative 1/2, negative 2. All right, let's plug in, shoot, you know what? Let me plug in negative 1. So if I plug in negative 1, I would have 1 over negative 1, which is negative 1. So I have the point negative 1, negative 1. All right, you know what? Let's plug in negative 2. Sorry, I'm going a little backwards. 1 over negative 2 is negative 1/2. So when I plug in negative 2, I go negative 2 left and then down negative 1/2. All right, so that's that part of the graph. I'm going to talk about these things called asymptotes. Asymptote, if you remember, that's where the graph will kind of go all the way up to it, but never quite get there. All right, so now let's plug in some other numbers. Let's plug in 1/2, 1 over 1/2. Well, I would do keep, change, flip. I would get 2. So when I plug in 1/2, I go to the right 1/2 and up 2. My next point I'm going to plug in is 1, so 1 over 1. This is, by the way, the graph, right, that I'm doing. 1 over 1 is 1, so I have the point 1, 1. Next point here, I'm going to plug in is 2, 1 over 2. So I get 1 over 2. So when I plug in 2, I go to the right 2 and up 1/2. Notice, this graph looks like this, okay? And my asymptotes here are the x-axis and the y-axis. It'll never hit the x-axis and y-axis. I want you to think about that. Where is this undefined? Well, it's undefined when x is equal to 0. All right, so x is never going to be equal to 0. But also think about this. What will y never be equal to? Well, if this is never going to equal 0, my y will never equal 0 too, okay? All right, I'm just going to keep going here with this. I don't think I'm going to hold you that responsible for this, but here's the deal. I'll hold you responsible for this maybe, and we'll get as far as this. Here is a graph, okay? I want you to remember these points. See these points? These 3 points here and these 3 points here. Those are 3 points of the parent function, okay? In other words, those are points of y equals 1 over x. So what is it that we think that these two things right here are doing to my graph? Well, this plus 1, remember how I talked about it in the beginning? Y is equal to a over x minus h plus k. Remember I said h represents your horizontal shift? That plus 1 means I'm going to shift 1 to the left. Okay? See, because it's minus h. That 2 is my vertical shift, that or the k. That means I'm going to go 2 down. So I'm going to take each one of these points here and I'm going to shift them 1 left and 2 down. Now, I could think of it that way, or I could think of it as this is going to be my, this is going to mean that my, my asymptote shift. So think about this. I'm going to take all of this entire graph and I'm going to shift it 1 to the left. Okay, so look, watch this. My vertical asymptote is going to be right here instead. Okay, and my horizontal, if I shift up, or sorry, down 2, that means my horizontal asymptote is going to shift down 2. And I'm just going to make my graph look like this. See that? And then I'm going to go 0, and I'm going to go like that and that. Okay? That's my graph. I'm trying to think if I want to teach you guys anything else. Yeah, I want to talk about vertical asymptotes, I guess, and horizontal asymptotes. All right, a vertical asymptote, guys, is where your graph is undefined. It occurs where your graph is undefined. So for this example here, where is my graph undefined? It's undefined if x was equal to 4. So that would be my vertical asymptote. X equals 4. Okay? Horizontal asymptotes, they occur differently, okay? Here are my things for a horizontal asymptote. Oh my gosh, let's kind of scroll. You know what? We'll talk about it in the next class about it because I don't want to have to go through all of this. But the horizontal asymptote occurs where your answer is undefined, okay? I'll just leave it at that for now because I know I gave the last video was very long. So anyway, just kind of keep some of this in mind. We're kind of racing through. Sorry about that. And do the homework. Okay, thanks. Bye.